Hello class, today's learning goal is I can represent equivalent ratios, also known as proportions, on a graph and in a table. So let's get started. So here we have a table that represents a proportion of x to y. X to y. Now, we know this because the proportion of negative 8 to 10 is going to be the same, the ratio of negative 8 to 10 is going to be the same thing as negative 4 to 5, negative 3 to negative 3 to 3/4, 1 to 5/4, 2 to 2.5. So let's check that. Over here, negative 8 to negative 10, the simplification of that is going to be negative 4, or excuse me, negative 4 to negative 5, in which case we get rid of the negatives, so it's just going to be 4 to 5. That's the ratio for negative 8 to negative 10. Same thing happens over here. Negative 4 to negative 5 simplifies again to 4 over 5. Negative 3 to negative 3 and 3/4. So that's going to be a little bit more complicated, so let's go through that one. It's going to be 3 divided by this, if we make this an improper fraction, it's going to be 12 plus 3, which is 15 over 4. Now we have 3 divided by this fraction right here, so we do keep, change, flip. So that will be 3 times, we can do that, times 4 over 15. The 15 and the 3 cancel out. We get 4 over 5. The same thing applies with 1 and 45. Or excuse me, 4 over 5. So that's again keep, change, flip, so it's going to be 1 times 4 over 5, which again gets us 4 over 5. The last one that we need to check is 2 and 2.5. So let's try that. It's 2 times that's going to be 2 over 5. Because 2 times 2 is 4, add 1 is 5, so that's 5 over 2, you keep, change, flip. So we get our ratio of 4 to 5 again. All of these have a ratio of 4 to 5. The only exception to that, you may have noticed, is 0 to 0. 0 to 0 does not get us 4 to 5. It gets us, well, depending on how you define it, 0 or undefined. Usually most people consider it undefined. And 0 to 0 is the lone exception that is allowed. Okay? That is because when you have 0 of something and you have a ratio of 4 to 5 of something, the other person has to have 0 of that as well. So if the ratio of stamps for one person to another person is 4 to 5, and one person has 0 stamps, the other person also has to have 0 stamps as well. Okay, and this is the lone exception of why fractions are a little bit weird when using ratios, because technically in fractions this is not allowed, but we allow it when we're talking about ratios. Let's take a look at another table. This table right here is not a ratio. Over here we have a ratio of negative 9 to 1. Over here we have a ratio of negative 8 to 0. The next one is negative 7 to negative 1, or also known as 7 to 1. None of these pairs end up giving you the same ratio. Okay, because of that, this does not represent a proportion. In order to represent a proportion, x to y has to be the same thing for each one of these. Okay. Now let's talk about graphs. Talk about graphs. We're going to use this. Navy collects 12 coins each year and use equivalent ratios to graph the growth of his coins over time. So it says step 1, write an ordered pair for the first year. Let the x-coordinate represent the number of years, and the y-coordinate represent the number of coins. So over here, this is coins. Imagine that says coins. There we go. And years. The next thing it says is to make a table of equivalent ratios. So first off, the first point should be right here. Okay, 1 year, 12 coins. 1 year, 12 coins. Next is to make the table. This should be 24. So that should be 24. Because in the second year, he's going to have 24 coins. That's right here. Over here, this one should be 36. Apologize for the bad handwriting. 3 and 36. 4 should be 48. And 5 should be 60. I'm adding 12 each time because he gets 12 new ones each year. Okay. So we have the ordered pairs right here. I'm not going to copy them down here, but you should because my pen is not cooperating today. Give the graph a title and label 2 axes. We can call this coins. Coins collected. Coins collected. There you go. Over here, we've already labeled 2 axes, coins and years. Over here, the point 112 represents the years Navi started his collection. It shows that he had 12 coins after 1 year. Using the graph at this rate, if Navy continues to collect coins, how many will he have after 8 years? So what we need to do is make a line that connects all of these points. And we know it's going to continue like this. All the way over. And just like we did in the last chapter, we're going to go to the 8th year, look up, and then look over. He should have 96 points. Now, whenever we have a proportion, this line right here should be a straight line. That's because the proportion is represented in the slope. If we calculate the slope is going to be 12 in this case. And in this case, our ratio is 12 coins to 1. Let's get rid of that. 12 coins to 1 year. That's our ratio, and that's represented inside the slope. Because it's 12 is the rise, that's coins, and years is the slope, 12 to 1. Or excuse me, is the x, 12 to 1. Okay? If we were to take a look at the next one, Edna walks a rate of 3 miles in 1 hour. Write an ordered pair. Let the y coordinate represent miles and the x coordinate represent hours. This slope is going to be 3 because hours is going to be our independent variable. Miles is going to be our dependent variable. We're going to go 1 to 3.